Can everyone see my slides? Awesome, thank you. Hi, yeah, I'm Jose, again, presenting with Morgan and Matt. I will be talking about kind of what is imputation, why people might want to do imputation, why we think our service is useful, and then some little bit of background, but pretty high level, not delving too deep into what we do. But yeah, so I'm presenting on the All of Us in AnVIL Imputation service. Um, DSP and Broad Institute were the ones who developed it. The link down there is kind of the link to our portal, which will be demoed after this, as well as a CLI. There'll be a bit of information, then the UI, then the CLI. It's kind of the parts of the demo. Okay, so why might someone want to do imputation? There, there is a trade-off between like depth and sample size. So there is whole genome sequencing, which has a lot of data, but it's pretty expensive. Recently, there's just kind of this new, very common low pass whole genome. So, at the exome, it's pretty deep, and there's the whole genome, it's like 1 to 2 to 3x. A lot of people like that. And then like kind of an older sequencing, it's still done. It's not as common nowadays, I would say, but is arrays. But the benefit of, arrays and low pass is they're generally much cheaper. It's kind of the difference is kind of smaller now than it was, 10, 20 years ago. And that difference gets smaller and smaller, but it's still a bit more costly to run the sample through whole genome versus low pass and arrays. But the downside to low pass and arrays is that they have much less data. So if you're looking for anything like outside of the exome area, you don't get a lot of data for, low pass and arrays. But that's where kind of imputation comes in. So what is imputation? Imputation is essentially the easiest way to describe it is like you take a sparse data format. So here, I hope you can see my mouse. Can you see my mouse? Okay, cool. So here you have like your sparse data format. So here would be like arrays or low pass genomes. And so you have like a lot of blanks, right? So the underscores are blanks. And you want to fill in those blanks with like your best guess. And so here, this is where the importance of your reference panel. I'll refer to reference panels a couple times throughout this presentation. But this is essentially a resource that you pre-compute based on a less sparse data source. So in our case, our reference panel is based on 30x whole genomes. And basically, you take your sparse data, you kind of run like it's not a complicated algorithm, but a way to basically match of like, okay, like which of these match up with the data that I do have, and which of these am I most confident? Like, oh, okay, well, this matches here. So what do I think the imputed or like filled in data would look like? So the important part of this process where you're going from here to here is really how good is your reference panel? How well represented is your sparse data in your reference panel? So this comes down to size and really diversity of the reference panel. Like if your input sample is not representing your reference panel, your imputation is probably not going to be very good. So that's kind of the gist of what our imputation service is trying to do and trying to do well. So why is it important to have diversity in your reference panel? Um, I think a lot of us know this, like non-Europeans are pretty underrepresented in genomics. This was some data that were taken recently from like the end of August, the kind of GWAS participant diversity. And you can see Europeans kind of dominate 90%, and then everybody else, takes up the other 10%. And so this is something we kind of all know, and we're all trying to work towards making better and kind of representing those other diversity or the other ancestries as well. Why is this? Why can this be a problem? There are lots of reasons. These are kind of the generic reasons that people know about. But basically, if you're not well represented in the science that's going on, you can have inaccurate results. You can be undetected entirely, like we don't even know what's going on because you just don't have representation in the data we're looking at. Even worse, you could have like incorrect diagnosis because you're just not comparing the same thing from, A to B. And along with incorrect diagnosis, you can have ineffective treatments. So yes, this is not great, right? You want to have diversity. You want to be well represented, in your healthcare and your genomics and all this stuff. Like, this is all very important. And so what do we think we bring to the table with our service that maybe other servers don't do as well, and that is adding to that diversity of our reference panel. Um, and this is kind of the power of our imputation service. We built a reference panel that combined all of us and AnVIL CCDG data. For the most part, there are some samples we left out, but for the most part, it was all the samples in both of those data sets. And that led us with a reference panel of around a little bit above 515,000 samples, which in its own is the largest ref panel that we know about, at least that is powering an imputation service. And as you can see here on this chart, it's not only the largest, but also the non-European portion of that reference panel is also bigger than any other reference panel. So we are large and diverse, which is the whole point of why we wanted to do this. You can see like here's a couple other reference panels. But yeah, like this is kind of the part we're most proud of, this green line, that like we have such a large diverse ancestry as part of the reference panel. Sure, a lot of it's also European, but I think it's like 49%. But yeah, so this is why we think this is where the power of our imputation service is going to come from, is this ref panel. A little bit more breakdown of the reference panel itself. So again, a little less than half is European, and you can see the percentages breakdown of the rest of the ancestries. And so the nice thing about this is that you can see, like, for different samples, you can look at different references and be like, oh, my sample is East Asian. Like, what would be the best reference panel to use? And you can look at something like this, and look at the other references that we had in the previous slide, and be like, which one gives me the most representation? And that's the one I probably want to use because it's going to give me the best result at the end of the day. So again, yeah, this is kind of to go on to the previous slide. So how well do we actually do with different ancestries? So we did a couple of scientific validations. We'll talk about one here. And here we took 48 samples, 48 core samples, I believe. And the reason that we did larger validations, but the reason we're talking about this one is because this is one of the ones we actually could compare between our reference panel, the all of us AnVIL reference panel, and the TopMed imputation server. And so what we did here is we had 48 samples that we had GDA array data as well as 30x whole genomes. So we used the 30x as a truth, and we imputed on the GDA samples. And I'll show you the result on the next slide. But here, this is just a breakdown of the inferred genetic ancestry. So we have African American, Adams American, Southeast Asian, non-Finnish European, African, and East Asian. And so then how did we compare to TopMed is here. Again, this is pretty high level. Happy to dig into this more after the presentation. But generally, you can see across every ancestry other than African, we seem to we do outperform TopMed. So the red line is all of us an AnVIL ref panel, or our service, and the blue line is TopMed. And you can see so African is the one where we do not do better than TopMed. And that kind of makes sense because we don't really have the AOU, which is a large part of our reference panel, is American. So we don't have a lot of representation, of like the actual African ancestry, which is it's a good thing that we can see it because it means like what we're doing makes sense. Like this makes sense that we're not better than TopMed in that particular ancestry because TopMed, their result does have representation of African samples. So it's we'd like to be better in all the ways, but this makes sense and it's good that it aligns with our expectations of our reference panel. So it's good. And you can see like the biggest disparity is more on the rare side of variance, which is kind of what one of the benefits of being large is you can see more instances of rare variance. So it's good that we see that we're better not only kind of across the board of all allele frequencies, but we're definitely a lot better at the rare allele frequencies, which is what we want to see. Otherwise, there's no real point in having the service. So this is all good. And so yeah, so that's the kind of one of the validations that we did. We had other ones that we can talk about later, but for now, this is just the only one we'll talk about here. And then, so how does the service work? I like to say it's pretty simple. Essentially, a user makes sure they have enough quota to submit the samples they want to submit. They submit the samples to our servers, either through our portal, which will be demoed after this, so our CLI, which will also be demoed after this. Then our service uh, performs our analysis on those inputs, and then we make available the output files for download. And you can download, or the user will get an email basically stating, oh, your workflow's done, feel free to download. And then they can just use, again, either the portal or the CLI to download their results. That is it for this part of the presentation. I believe, Matt, you were going to go first with the UI or the portal demo.
Yeah, I'll get my screen share set up real quick.
We'll stop sharing.
All right, so hopefully you can see the landing page here. All right, so welcome to the demo portion of today's presentation. I'm going to be doing a walkthrough of the user interface for the imputation service, which you can find by going to services.terra.bio. So when you first go to our portal, you'll see this landing page. You can sign in using a Google or Microsoft account. And if you already have an AnVIL or Terra account, you won't need to go through the registration flow again. You can use the same account, although it is very quick to register if you're new. So I'm just going to go ahead and do that now. I don't think you'll actually be able to see the pop-up that just showed up because I only shared my one Chrome window, but it's just a standard Google login. So I'm just going through that right now. Um, and yeah, so the first thing you'll see when you log in is the most important page, the run job view. This is where you'll configure your imputation jobs and learn more about the pipeline. Before I run a job of interest on the right-hand side here, you'll see there's a few boxes with information. At the top, you'll be able to view information about your quota. So the service uses a quota system, so every user will have some initial amount of free quota thanks to NIH funding. And then you can also request additional quota by reaching out to our team here at the request a quote link. And if you're curious to learn more about how the quota system works, you can follow the Get Help link there to our documentation. Um, Below that, you'll see the expected pipeline outputs. So these are the files that you can expect to receive after a successful run of your selected job. So for this pipeline, we return an imputed VCF with its index, as well as a TSV file containing some QC information about your run. And then lastly, we've got a couple of helpful tips here. Most of the helpful tips are going to be at this link for formatting guidelines at our documentation website. So you can follow that to learn more about how you should format your VCF before you run the job. So now for the more exciting bit, I'm going to run a array imputation job. So you can see that there's a drop down here with just one version currently. As new offerings and versions become available, you'll be able to select those as well, but I'm just gonna use the default. I'm gonna give a output prefix of demo. So this will just get prefixed onto all of the output files. And then you'll note that there's an optional imputation quality score that I can fill out here. So this just allows you to exclude outputs below a certain quality score from your final output file. I'm just going to keep the default to 0 so I get everything. And then I'm going to give a quick description, October 15th, AnVIL demo. And lastly, I'll select an input VCF file. This is another thing I don't think you'll be able to see on my screen share, but I am just using the standard file picker to select a VCF. So you can see that's all good. Everything's filled out. So I'm just going to submit this now. It's going to upload my file, and the job is now submitted. So the runtime is going to be variable based on the inputs, but you'll receive an email notification when the job completes. Since that one's going to take a little bit, I'm going to go over to the job history tab at the top. and show you what an in-progress job looks like, as well as failed and succeeded jobs. So you can see the job that I just submitted is in progress. And then I've got a couple of successful jobs down here that we can view. You can see that this one consumed 500 samples from my quota, and I can view the outputs here. Here are the three files that I expected to receive after a successful run. You can download them, and you have up to 14 days to download these files before they are automatically deleted. So you'll want to retain your own copy of the output files before this date. Um, and then additionally, for any jobs that have failed, we also try to run some QC checks on the inputs before going too far in the job process. So we want to return some useful error messages to user. So you can see here for this one, I ran a job with an input VCF that was on an older version that is not supported. So we just try to return helpful error messages where possible. Um, so I think that concludes the UI demo portion. So I will pass it off to my teammate Morgan.
Super, thanks, Matt. And I'll share my screen. So in addition to the web portal, we also have a command line interface that you can use to run imputation through run this service. And so you might want to use this. There's a couple motivations why you might want to use this over the portal. It's more automatable if you want to automate running imputation. It's easier to use a command line interface. And additionally, for now, this is not super relevant because of the 2,500 sample limit, but being able, if you ever want to upload something that's a bit larger, and you trust the command line better, if you're just more comfortable with command line, you might want to use command line. And I can also mention you can use this tool from an AnVIL VM. I'm happy to show that if people are curious, but we have information in our documentation about how to do that. But for now, I will just show you the TerraLab command line tool. So I'm here. I'm going to run this in a virtual environment. So I'll just set that up sort of from scratch so you can see how you can download the tool. So I will activate my virtual environment and then just use pip to install the TerraLab CLI. It'll install the latest version. Take a couple seconds. All right. So now we just take a second to look at the help menu. Basically, this tool allows you to do all the basic things that Matt also just showed in the command line. So you can submit a job, you can learn about a pipeline. Right now, again, we just have the one pipeline, but as more offerings are added, you could get more information about those. You can look at the jobs that you have. You can download your outputs. You can check your quota. So essentially everything you can do in the portal, you can also do from here. So for example, if I wanted to look to find more information about the array imputation pipeline, first I can list the pipelines. Aha, yes. So if I've not yet authenticated, so this is going to prompt me to authenticate, and I'll go ahead and do this. It's interesting. There we go. I'm not sure why that, usually that doesn't take quite so long. So then I've authenticated, and here's the list of the pipelines. So again, we just have the one array imputation. If I want to know more now about that pipeline, get the details about array imputation. And so here we have a little bit more information. We have the description, the minimum quota consumed by a job. Here are the inputs that I can submit and the outputs I can expect to receive, and an example usage line for actually submitting a job. So this is pretty helpful. So to run this job, the important thing, you can run TerraLab. Well, but first I'm just gonna show the things I have here. So I have I could run this on this is a full genome of 500 samples of 1,000 genomes, HTTP data, and this is just chromosome 20. So I'll probably use this one for this demo just because it'll be quick. So I will go ahead and do this. Submit. Imputation. So my multi-sample BCF is this one. This is that prefix that Matt was talking about. I'll just use the base name of that input file. I will provide a minimum quality score of 0.8, and I can provide a description. Okay. So when I do this, the CLI is going to go ahead and upload your file for you and start your job. And that is now going to be running. I can then, from here, look at all my jobs. So I can see that I've got this one that's running. I've got my previous jobs. This is all powered by the same backend as the UI. So if I go over to the UI, and check out my job history here. Here's that job that I just submitted. So you can kind of use the UI or the CLI as you use the portal or the CLI as whichever one you're more comfortable for different parts of this. So I could go to an old job that I'd submitted in the CLI and download it here from the portal. I could submit from the portal and then check it here. So it's all kind of interchangeable. But so if I did want to download my outputs from the command line, I can go to, here's a job I ran previously. All I have to do, well, I'll show you the options that you really only have to do Teralab download and then the job ID. But if you do want to, then that will by default download to whatever directory you're calling it from. If you wanted to download it to a specific directory, if I wanted to make an outputs directory, then I can specify that. So I want to download this job, destination, and outputs. And that's going to go fetch my download, my outputs. This chunk info is sort of a QC file. We're working on adding more helpful information metrics wise, but this and the index, of course, download quickly, but your imputed VCF downloads a little bit more slowly. And then, yeah, so then I could go explore that. And as I mentioned, I can also check out my quota on this page. So this tells me my quota limit, how much I've used, how much I have available. And again, this just matches the information that's going to be here in the UI. That is basically it. I also do want to mention that you can, if you can run this from a AnVIL or Terra virtual environment. We have some documentation. You have to do a little bit of setup to get this to work in a VM. But if you start so this is an AnVIL workspace, and if I started a VM, you probably want to give it a lot of enough disk to support, because you're going to need to copy your inputs into the VM and then download the outputs to the VM and copy them back to a bucket. But you can run this from a terminal just the same, as long as your inputs are allowed to be exported, as long as those files are allowed to be exported from your bucket. And so I just wanted to mention that, and we could talk about that more if people have questions. But that is, I think, the end of what I want to talk about. So I think that's all we had prepared, and we would love to take questions.
Fabulous. Thanks, Jose, Matt, and Morgan. Appreciate it.